Welcome back to Barley and Hops. I'm George. Before we even get started, here's a real quick tip for you. Heinz tomato ketchup, copper rod. I just spread some tomato ketchup across here. You allow it to sit for a couple of minutes because tomato paste or tomato ketchup, is really acidic. And just give it a good scrub. Now, in a pinch, this is probably not the best method, but this is a method of cleaning copper. There. Good tip. We're going to introduce this still behind me, and you need to see all of this. We're so glad you decided to join us today. I want to introduce this still to you. This is the Mile High 16-gallon still, and I need you to understand up front that this is probably the top of the line model for those who are looking for something in that area. Okay, this is probably about the limit for a home distiller. Anything above this, you're probably not home distilling any longer, if you catch my drift. Oh, now, by the way, that idea I showed you, that's not mine. I got that from a viewer. It's amazing. There's a little bit of tomato ketchup, and that really comes in handy to clean some of those large pieces of copper that you have. If you're just trying to get a good clean off of it, because it's awful hard to soak things like that. Yeah, of course, Tarnex works. I mean, there's a bunch of different chemical products out there on the market. But if you've got some tomato paste or tomato ketchup set aside, why not? I will probably use that again and again and again just for some superficial cleaning. Oh, now I want to introduce this thing to you. If you haven't had a chance to subscribe yet, please do so. It's on every one of the videos. It costs you absolutely nothing. And yes, that's the only way we benefit. So if you have subscribed, thank you very much. If you haven't, please do so. It's there for the taking. Now, this is the 16-gallon. You can see this thing is beautiful to start with. Just the sheer shine and the quality of the material, this 304 stainless steel, the quality of the material just kind of pops out at you as you go through. And you can see here, there's a little bit of the unboxing routine I went through. So many boxes, so much packing. And each one, it's like being a kid in a toy store or, a young kid on Christmas opening up packages and discovering what is there. Really, really amazingly packed, and the quality of the product is really, really high. Now, one thing I'll show you is, I always do this with a magnet test. There's nothing about this still that is magnetic, and doesn't even have a magnetic base. So this will probably not work on an induction cooktop. But then again, I don't know of an induction cooktop big enough that would handle a 16-gallon still to start with. So that's a dead issue. So whether it's magnetic or not would make no difference. Knowing that it's not magnetic does indicate that it is fully stainless steel. You've got this large, I love this. This is a large butterfly industrial size or industrial style exit port for dumping the remaining mash out when you're finished, and it's just really neat. Of course, they all come with a thermometer mount for inside the kettle. You already know what we think. There are times when tracking the kettle temperature could be a little helpful. It's kind of indicators, but don't run your still based on the kettle temperature. You always run your still based on your head temperature. Okay, if we work our way around the side, it has two ports. These are 2-inch ports. That one's capped off. This one's left open for the 5,500 watt element that I'm going to use in order to heat this up. I mean, what more can you say about it? It's a full 16 gallons, so it will hold quite a bit of mash. Now, a couple of the things that I want to show you is, first of all, the condenser. And this condenser, this is, again, one of those large, long, which is probably 24 inches long. It is a very, very efficient condenser. It's a shotgun condenser with 7 tubes in it, and each one of those are 1/4 of an inch. So you've got a whole lot of cooling capacity or vapor flow area and cooling capacity in that long condenser. Let me set that aside and move on to the other interesting aspects about this thing. The deflagmator that goes at the very top, and we're going to show you how to assemble this. And also, by the way, in this process, we're going to do a video on, and we're going to answer the question, well, how do you run it? What is the process of establishing a balance column and the transfers, and how do you actually make it work? Because there's a couple of different methods, and you need to understand all of them because they're all relatively simple, but they're key elements in actually how do you run a flute still. This is a deflagmator, and that has 7 3/4 inch holes, tubes through it, and that allows for a large volume of vapor to flow and condense and drop back down into your column. And of course you can control that by allowing a certain amount of those vapors, once purified, to exit the top of this. And additionally, this is something that I really needed to show you a close-up, is this was what considers it a flute still, but they're bubble plates. So this is the bubble plate attachment. It comes with 6 of these, and they also have a model that comes with 4 of them. This is the 4-inch model. The front sight glass is screws on, screws off for easy cleaning and access. And if you look around here, you can, first of all, you can see the quality of those welds, and that is copper to stainless steel here. And this is also copper to stainless steel here. You can see the quality of those welds, which this is relatively thick in comparison to a lot of other products. That and the outside temperature versus the internal temperature. So this thing is fairly insulated all on its own. It weighs, this one piece weighs a little over 4 pounds, and that is right at 2 kilograms. So when you put all of these together, this does become relatively heavy. So have someone help you if you are inclined to need a little bit of assistance. Let me show you the rest of this. Now this is just another version of the bubble plate. Instead of there being multiple bubble plates, what they have here is they've got 136 of these small holes that have been drilled into this plate with one downcomer. And this downcomer is a 3/8 inch inside diameter, and all of these holes are 1/16 of an inch. And what that is, and make sure if you're going to build one of these on your own, you're going to make your own bubble plates, is make sure you don't go any larger than about 1/16 of an inch in these holes, because that's just about the right size to allow that liquid with enough vapor pressure moving up to develop a pool that will start to balance, bubble and balance on top of that plate before it, of course, overflows into the downcomer and drops down into this collection vessel, and then it starts to vaporize from here as well and bubble out. So what we've got a distillation taking place, and we've got this downcomer where another distillation's taking place. So when you put these together, you've kind of got like the equivalent of 2 plates, at least in theory. How this thing goes together is it is rather straightforward, but I'm going to show you this piece by piece as I put this together as well. Something else I wanted to show you was that in addition to the remainder of the still as it's put together and it's assembled, the Parrot becomes part of the still itself. So you no longer have to adjust a Parrot or move it around or add one to it, because it's part of the still system. And this is connected on the bottom of the condenser, where the Parrot would start to fill up, and then of course you can track it at the same time. Now that it is a permanent piece of, that's attached, a permanent piece of the still, it kind of begs the question, well, what about 4 shots and heads? Well, that's simple. They put a valve on the bottom so you can open up that valve. It's a butterfly valve, and it actually dumps all of the contents in your Parrot so that you can go from your cuts from your 4 shots and heads to your full collection without the worry of it mixing or wasting anything. Oh, this is a phenomenal setup. Now, let's get a close-up, because what I'm going to do is I'm going to start to put this thing together. And of course, there's more than one way to skin this cat, but I'm going to show you the one that I figured out. Now, the first section that we're going to add goes on right on top of the kettle itself, and then you just lay this gasket in there, and it has a ridge that goes around the depress that goes all the way around here, so it fits in nice and snug. And then the bubble plate. Now remember, the bubble plates go on the bottom of each section, and there's a reason for that, and I'll show you that when we get to the top. But just all you have to do is think about how this thing actually works. And then your bubble plate lays right there directly in the center on top of that gasket. And then we add one section. One section with a tri-clamp. And call me anal, I always put all my tri-clamps on the same side, which in this particular case is on the back side, and I have them oriented in the same direction so it looks kind of neat and clean when we're finished with it. Now these only need to be finger tight because they compress and they will clamp down, and they clamp across that gasket so it seals it up. And so inside here you have the downcomer, with the downcomer going down inside the kettle, and then you have the bubble plate that is visible in the bottom of this section. Let's get to the next part. Now it's time to start adding the rest of the sections. Now, I have found that assembling a couple of sections here and then attaching that complete set on here is a little bit easier for me anyway, instead of putting them on individually on top of the column. Although it's the same thing in the end, I just tend to do it that way. The first thing you want to do is you want to take, because your bubble plates always go on the bottom of the section, and they go in this direction, you place a bubble plate on the section that is sitting on top of the kettle already. And I always put the downcomers in the back of the column so that I can see through the front glass, and you can see them in the back. Doesn't really matter. You can put them on the left, on the right, on the front, on the back. It's a sealed system. All right, I'll place that there. Now what I'll do is I go to the rest of these, and then I just put a gasket and a bubble plate and a section. And then line these, of course, line these sight glasses up so that they're in line with each other. That looks pretty neat in the end. It really looks awful when you got one countercocked off one side. Now, I'll take these three and place those on top of the one that I already put on the still. Line up my sight glasses. Then add my 4-inch tri-clamp. Now this thing looks really, really pretty with all 6 of these on here. In this particular case though, I'm kind of challenged with height. I do have a recess here where I've had it assembled, and it goes all the way up inside my recess. But in the interest of space, and to be able to show you this and describe how this thing works, I'm only going to put 4 of these on here for right now. I'll leave the other 2 for when we actually run this and we demonstrate how this actually operates and how you need to attend to it. So the next part that goes on here is, yes, you guessed it, the deflagmator. And the deflagmator, you can put this and you can orient the in and the out ports anywhere you want. I like to orient them to one side so that I can kind of keep track of where things are going or where they're coming from. It just makes for a cleaner setup. Now the next piece that goes on is going to be the adapter that goes from, you're going to love this part. Goes from a 4-inch to a 2-inch, and I've got my port here for my thermometer, because where do we measure the temperature? We measure the temperature at the head, and that is going to be above the deflagmator. And that's the temperature that we're going to use to make adjustments in water flow as to whether we are either fully condensing or partially condensing, and adjusting based on output from our reflux chamber. Now, you remember we looked through those, and you can see in all of these sight glasses, you know, you've got a bubble plate there. So you've got 1, 2, 3, 4 plates, but you've got those additional downcomers. So it would be safe to say right off the bat, without doing the long calculations, because there is a calculation for it based on volume and distance, where you can include a theoretical plate. You've got at least 2 in each one, so you're looking at 8 distillations that take place at one time. Put 12, or the other two on here, and you have 12. So let's just keep going. Now, you'll notice this one, oh, there, my clamp is already there. I had it preset. We've got a gasket, and we've got this crossover tube. Now, this crossover tube, better known as a line arm, you'll notice that it already has just about that 3-degree slope that you'll notice in a lot of traditional stills. And what that's for is for your still and your condenser to take advantage of gravity as your vapors start to flow through your line arm, that will naturally flow down into your, oh yeah, it's over there, your condenser. The next part is actually the condenser, and this is probably the one that's a little bit, not tricky, but there's so much weight on this thing that it's not as easy to hold and attach as all of the other ones are. It takes a gifted set of hands, of which I do not have. Hang on here. Oops. Yep, I got it. Wow, right the first time. Okay, now it's time to talk about this real quick, is your water flow. Of course, water flows in the bottom and comes out the top, because we know that the effectiveness of a condenser is achieved, at least the proper effectiveness is achieved, if the water flow that you're using as a cooling medium is opposite the direction of the vapor flow. So what does that tell us over here? The vapor flow is this way, so we should run cold water in here and out here. But at the distance that we're traveling, it's really not going to make that much difference which one of these we use. But in theory, if we're following the proper procedure, we would run cold water in the top here, because it would be counter of the vapor flow. And over here, we run it in the bottom, it comes out the top, because that would be counter to the vapor flow. Now here's an addition that takes it from a 2-inch down to the small 1/4-inch connection for the Parrot. And that's all that is. And you'll notice that there's a vent here. And what's that vent allow us to do? Well, that doesn't allow us to do anything, but it allows atmospheric pressure to be introduced and keep the system open and allow the liquid to flow evenly. Oh yes. One added Parrot. And then last but not least, and this is the dial thermometer that comes with the system, goes right here. Now I could put any other, and I do have some other thermometers, you know, K-type thermal probes that can go in here as well. It doesn't really matter at this point, as long as you have some sort of a mechanism in which to follow your temperature. This is really the whole system all together. And you notice that it only took, what, 10 minutes since we started just to get to this point. So the only thing left really to do is to add the heating element. And this came from Mile High as well. This is a 240 volt, a 5500 watt element, and that goes into the side of the still. And additionally, yes, I could use a PID. I could use a bunch of different methods in which to control this, the element itself. But I'm going to use the one that's provided by Mile High. And this one's rated 240 volts. And it will run that 5500 watt element rather efficiently. So I've got, of course, a volt amp meter, and I've got my variable control and on and off switch. I'm just about ready to go. Last but not least, get in touch with Mile High. Go to milehighdistilling.com if you're interested in one of these. Again, I've got the other two sections of the bubble plates that I will add to this still. And I'll add these when it's time to run this, because we have to do, of course, we've got to run this thing through its paces and find out what it's capable of doing. Until next time, join us when we run this. Happy distilling.